This is the Coral Chamber final prototype, and now I'm going to show you around. Right here we've got a flow chamber. It's made out of black ABS plastic, and this is where you'll mount your slide. This elevator mechanism here allows the coral to move up, out, and you can even rotate it by lifting this up, finding an appropriate spot, and replacing it back down. The coral will be mounted on the bottom of this. There's two lights to help illuminate the whole project for the experiment. Now, how the water gets into the flow chamber is due to the supply bin. Inside the supply bin, we've got a water heater. We've got a fan that induces evaporative cooling. We've got this bypass valve, this bypass tube that allows the water to stay at the 16-liter mark. Additionally, we've got this valve that will allow the water to flow into the flow chamber to stop at any given moment, given the circumstance. Controlling this whole apparatus is this electronics box. This electronics box is turned on and displays the set temp and the temperature that it's currently reading. It's reading the temperature through this water temperature sensor, and the set temp is controlled by this knob. As you could guess, the set temperature is the temperature you're trying to keep the water in the system at. So right now it's at 24.8. It's currently at 24.94, and that's why you have our fan is on to cool it down. Additionally, on this box we have our relay lines, and these are connected to the pump, fan, and the heater. That's how we control all the aspects of this. This is how we control the heating, and this is how we control the water flow. Additionally, we have an on-off switch on the back. This allows the system to be shut off at any given time. Now, to control the lights, we use these knobs. These will change the saturation of red, green, and blue in both lights, and this is for each light. Additionally, we have our pump down here into the collection bin, as we call it. So this is water coming from the flow chamber right here. This is water coming from the bypass line here. And here's our pump that's pumping it up. One of our design criteria was to keep water inside the system. That's why we've implemented two water level sensors. The one, as you can see in the back by that red light, that will turn off the pump for 2 minutes when it touches water. Nothing else will change as the experiment can continue as this water level is controllable. Now, this water level sensor will be mounted inside the flow chamber. This is a more critical junction to not have water overflow. If this gets triggered by having it touch water, as I'll do right now, this fails safe. We'll stop the entire system. As you can hear the fan turned off, these LEDs are going to shine red. The pump's off. You're going to get this LED's red. You're also going to get this message here. This will shut off the whole system, turn off the valve, and allow water to flow, and researchers to change it. It's given a kink in the line or something like that. So overall, there's around 23 liters of water in this entire apparatus. And the bottom of the collection bin compared to the bottom of the supply bin is around 3 feet.